include the interaction term in your model, but the interaction term become slightly more complicated with interaction term in your model. Okay, so now you have obtained the preliminary final model. To obtain the final model, we need to check the model assumption, or the in logistic regression, we call it the assessment of goodness of fit, right? So three method. One is Hosmer-Lemshow test, the other one is classification table, and the last one is the area under ROC curve. Okay, so Hosmer-Lemshow test. So let's obtain the first one, the first assessment of goodness of fit, right? So we evaluate the preliminary final model using enter method. Under option, ask for Hosmer-Lemshow goodness of fit test. Right, then continue. Okay. Under block 1, look at the Hosmer and Lemshow test. If your model is fit, if your prediction model is a good prediction model, then the p-value must be not significant. So you aim for a non-significant Hosmer-Lemshow test. Okay, so a non-significant Hosmer-Lemshow test indicate that your prediction model is a good model, right? So meaning that your what you obtain is a fit model. Okay? The second table you need to assess is you need to evaluate is the classification table. Right? So the classification table is the indicate how many percent a correct prediction out of your model. Right? So it compare between observation, what you observe, CAD and non-CAD, versus prediction made by your model, right? So out of the observed and predicted probability, right? So you can obtain the percentage of correct prediction, okay? So here, the model can correctly predict 86.4% of the cases. Right, so higher correct prediction, of course, it indicate that your model is better lah. Alright, so classification table, okay, aim for a classification table of more than 80%. Okay, so classification table, like I've mentioned before, higher is better, but aim for at least 80%. Right, so the last one is area under ROC curve. So to obtain the area under ROC curve, first you need to obtain the predicted probability. Okay, so you run again your logistic regression preliminary main effect model, preliminary final model. Okay, and under save, click predicted probability value, predicted probability, then continue and OK. So in your dataset, you'll be given one new variable, predicted probability. Okay? So based on this predicted probability, you generate the area, you generate the ROC curve, receiver operating characteristic curve. Okay? Go to analyze. New SPSS, dia punya function, menu untuk area under ROC curve, dia taruh tempat lain. Previous version, area under ROC curve, they put it somewhere here. But version 27, they put it under classify, right? So go to analyze, classify, and area ROC curve. Okay, so your test variable is the predicted probability. Your state variable is your outcome variable, and you need to insert the coding for your categorical variable of interest. For example, if you want to predict CAD, then your state variable is 1. Okay, so take ROC curve with diagonal reference line and also standard error and confidence interval. Then click OK. Right, so you will obtain an ROC curve. Okay, so the ROC curve is the discriminant ability. Okay, the area under ROC curve indicate the discriminant ability of your prediction model. Okay, So if you do prediction based on these three variable, what is the discriminant ability of the model to differentiate a person with CAD and without CAD? So that is what area under ROC curve is all about. So here, based on your model, the area under ROC curve is 0.709, more or less 71%. Okay, this is the 95% confidence interval. Okay, so like classification table, higher discriminant ability or higher area under ROC curve indicates that a better model, right? So aim for higher area under ROC curve. Okay, the recommendation cutoff point is at least 70%. All right. Okay, so if you obtain an area under ROC curve of 70.9%, it means that your DERM model can accurately discriminate 70.9% of the cases. That is the discriminant ability of the model. Okay, so at the end, we can establish the final model. After we have completed assessment of the goodness of fit of the model fitness, in other words, we are assessing the assumption of the statistical test, like in linear regression, then only we can establish the final model. Okay, so this is the final model, consisting of three variables: diastolic blood pressure, cholesterol, and also gender. Right, and subsequently we can do interpretation for each of the variable. Okay, so in multiple logistic regression, we look at the influence of the first of one independent variable towards the outcome when the rest of other variables are being adjusted. Okay, so for example, for diastolic blood pressure, a person with 1 mm mercury higher diastolic blood pressure has 1.051 times higher odds to have CAD. Okay? When lower cholesterol level, when diastolic blood pressure and also gender is being adjusted. Okay, so for categorical variable, again, always remember to check the reference group. Okay, so here my reference group is female, right? So I'm comparing male in comparison to female. So male has higher risk or higher odds or higher likelihood to develop to have CAD. Okay, so based on multiple logistic regression analysis, so male had 1.488 times higher likelihood or higher odds to have CAD in comparison to women when DBP and also cholesterol is being adjusted. Okay. Okay, and lastly, you will need to present the result in a table, in an appropriate table. So in the chat folder, I have provided an example of presentation for both simple and also multiple logistic regression. So you can use that template in your proposal and also in your write-up. Okay. So this is another example. This is another example for a table for multiple logistic, right? At the footnote, you can write all the methods for assessment of multicollinearity, interaction, and also model fitness. Okay, so for general publication, there are various methods to present result for multiple logistic as well as linear as well as other types of regression. So always check with the journal for their recommendation. Okay, so in conclusion, binary logistic regression analysis is just like linear regression analysis. The difference is in the outcome variable. For logistic regression, you are dealing with a dichotomous outcome variable. In terms of interpretation, you need to interpret the odds ratio, which evaluate the strength of relationship between independent and also dependent variable. Okay, so you need to follow the appropriate step, the proper step, right? Beginning with univariable analysis, then variable selection, Okay, then checking interaction and also multicollinearity, assessment of goodness of fit, then only you need to evaluate the final model. Okay, always remember to use proper coding. Okay, code number 1 for your outcome variable of interest. Okay, and last but not least, differentiate between clinical and also statistical importance of the result. Right? Okay, so I think that's all. If you have any question, can demonstrate how to interpret. How to interpret. Macam mana? How to interpret apa? Salah. Can demonstrate how to interpret if there's significant interaction term. Significant interaction term, I think there's no one way lah to interpret the interaction term. Interaction term is not straightforward. Only. Okay, so if you have interaction term, always consult a statistician lah for help, right? Okay. Interaction term, dia panjang cerita lah. Interaction term ni. Not straightforward, right? Okay. Boleh tak? Okay, Raymond asked, can I ask which is the most preferred method for checking multicollinearity? Can you repeat again interpretation of collinearity matrix? So collinearity matrix is just based on correlation matrix. Okay, so correlation matrix is just correlation matrix. Okay, correlation matrix you just ask for bivariate correlation. Okay, bivariate correlation you put in all the independent variable, okay, and look at the Pearson correlation between the variable. For example here, the first one, 0.315, stand for the correlation between diastolic blood pressure and also serum cholesterol. Okay? Between diastolic blood pressure and sex, this is the correlation. Okay? And the other correlation is this one, between serum cholesterol and also sex. Okay? So if you have any correlation more than 0.8, okay, the value is actually arbitrary. Some people use 0.8, some people use 0.9. Some people, in fact, is 0.7 pun dia kata ada multicollinearity lah. Okay? So if you have a large correlation between variable, then you can suspect a multicollinearity problem. Okay? There's no one gold standard way to check multicollinearity. Okay, so use all the method. So here I'm using the correlation matrix. I'm assessing the standard error of estimate, and also I use linear regression analysis and look at the VIF. Okay, do not depend on one method alone, right? So always combine several methods because there's no one gold standard method in assessment of multicollinearity. Okay. If we include a factor P more than 0.25 but deemed clinically important, would it affect our final result? Would it affect our final result of multivariate analysis when putting all factor? No, it won't affect. Okay, it won't affect. You can include any factors which you think it is important, even though the p value is not significant. Okay, but you need to have a proper justification. Okay, so I asked if I were testing the correlation association between lab marker, okay, with certain outcome, mortality, and certain tests, expensive and limited, will be missing data. How should we? Okay, variable with lots of missing data will be excluded from analysis. Okay, you need to exclude variable with lots of missing data from the analysis. Okay, so you cannot include that variable in the analysis. Okay, I give you an example. Okay, so for example, serum cholesterol. Okay, serum cholesterol, lots of missing data in serum cholesterol. So you need to remove this variable from analysis. Okay, why? Because, so for example, if I have 4,000 cases, 4,699. Okay, if this observation, okay, this observation have missing data. Okay, only for serum cholesterol. Okay, only for serum cholesterol, this variable have this patient lah, participant have missing data only for serum cholesterol. If we include it in our analysis, okay, the software will exclude all these participant, even though only one missing data for the participant. Okay, so if there's substantial missing data within a variable, then you need to remove this variable from the analysis. Okay, you cannot include that variable from the analysis, so that's why it is very important to do data exploration before you do the analysis. Okay, right. Any other question? Okay, so handling missing data, if you have substantial missing data within a variable, remove the variable. If you have substantial missing data within a participant, for example, like this one, you have only two information, remove the participant. Okay, how many percent missing data is deemed significant? This one is arbitrary. Some people say more than 20%. Okay, some say if more than 10%, then it is significantly missing, right? That's again, that's no gold standard lah. It depend on your justification lah, right? And also it depend on how many observation, how many data do you have, right? So kalau your participant ada 30 aja, okay, then smaller amount of missing data you need to think about it lah, right? Okay, so I think that's all. We are running out of time. Okay, so after this, Dr. Siti Azrin, right? Dr. Siti Azrin will give a lecture on survival analysis. Okay, so if there's no other question, then I pass the session to Dr. Azrin, Dr. Siti Azrin.
You want to take rest or not?
Tak nak.
Tak nak.